Hello, this is Xinru. In this video, we are going to take a look at question 101, symmetric tree. In this question, we're given a binary tree and we have to check whether it is a mirror of itself. So we have to determine if a tree is symmetric. So what is a symmetric tree? Let's look into the example. So this tree is a symmetric tree, as you can see, and if you cut the tree in the middle, you will find out it's like there's a mirror, and you can look at all those nodes value are symmetric. And this tree is not a symmetric tree, although the node value looks the same, but the left and the right node are not symmetric. So how are we going to solve this question? So first, we need to know we need to know in this question to check, we have to check every node, and it is easier if we do a recursive function. And we already know from the previous video how can we check two trees are the same. So, but in this question we have to check if two trees are symmetric, not the same. So for example, we can go through this tree and check if first if the node this node is this and this node, we can compare these two nodes and find out if they are symmetric. So it's similar to how we check if two trees are the same, only that we have to reverse the left node and the right node when we call the recursive function itself. So now let's get into coding. So here we are going to define a function called rSymmetric. So in this function we can determine if two trees are symmetric. So the first if statement are the same. If both tree doesn't exist, then we can see they are symmetric. Because they don't exist, so we can see they are symmetric. And the second condition is if one tree exists and another doesn't exist, then we say they are not symmetric. And then we compare the value of both trees, and if the value are not the same, we see they are not symmetric. So up to this point we can see it's exactly the same as how we determine both trees are the same, but here is what's different. So we're going to return rSymmetric because we need to find out if they are symmetric, not the same. So when we call the function itself, we have to reverse the left node and the right node. So let me show you. We have to check if the left node of tree S are the same as the right node of tree T, and if the right node of tree S are the same of the left node of tree T. So we have to swap the left node and right node to compare if they are the same. So if the left node of tree S is the same as the right node of tree T, and the right node of tree S is the same as the left node of tree T, then we can see they are symmetric. And after we get this, so now what we need to do is we have to call from the root node, because root node is there is only one node. So root node of the given tree is only one node. So what we need to do first, we write an if statement, the boundary case that if If root doesn't exist, we will still say it's symmetric. And next, what we need to do is we need to call this function. We need to call this recursive function, and this recursive function should compare the root.left and the root.right, and we need to find they are symmetric. So look into this example, we need to compare root of left, so which is 2, and the root of right, which is node 2, and we need to compare them. If they are symmetric, then we do the recursive function onward. So the key point to solve this question is that we need to know the true meaning of symmetric. Is that we need to first determine if the root node are the same, and then we need to determine if the right node of the first tree and the left node of the second tree are the same, and the left node of the first tree and the right node of the second tree are the same. Then we say they are symmetric. That's the only difference between check two trees are symmetric and check two trees are the same.